Today, actually, you may or may not learn something that may or may not help you. I can be no more specific than that. And can I ask that you take at least decent notes, because this is one of those things that is not hard, and I don't even think it's confusing. But people just think that they know what they're doing and they don't really know what they're doing. Have you ever done that? Just wrote down answers that you thought were right just because you thought they were right, even though they were incredibly wrong? So here, write down. Here is a problem. This is actually not only scientific notation, but it is multiplying and dividing with scientific notation. Mult. That doesn't work. And I suppose we shall write down a problem of both. Write this one down. 2.4 times 10 to the 6th, and we will multiply that by, I guess, 3.0 times 10 to the 8th. How about that? Doesn't that not sound fun? Careful how you answer that. And then let's write down this one. 3.6 times 10 to the 8th divided by 3 times 10 to the 5th. I don't know if those are in parentheses or not. Now, just so you know, as a little side note here, if these were not in scientific notation, this is what it would look like. What is 2.4 times 10 to the 6th? By the way, it's not 4 with 6 zeros after it. You move the decimal 6 places over, so it's actually 4 with how many zeros? 5, because one of them gets taken with it. So 2, 4, 1, 2, 3, 4, 5. It is 2,400,000 times 3 with 8 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8 with a 3. Okay. And if you look at that, that could be kind of confusing, could it not? I don't know. Maybe it's not that right. You don't need to do this because the reason we put it in scientific notation is so that it's easy to work with. So you can scratch this. Watch how easy this is, children. It's obviously a time for a ooh and ah, not that we've ever done that here. Watch the 3-step process here. Step number 1 is to multiply the left numbers, which means this. You are going to multiply 2.4 times 3. Step number 1. Anybody in your head? Please tell me somebody can do 2.4 times 3 in their head. All right, I'll give it to you. It's 7.2. Right? 3 times 24 is 72, 7.2. We're just dealing with that now. Okay? Step number 2, ladies and gentlemen, is to write down the times 10 part, because you're going to write this in scientific notation. Times 10. You want me to go over that? Did that confuse anybody? Just write down times 10. Flossing is good with you? You think that's very simple? Now, step number 3, okay, you are then going to multiply the right things together, okay? But to simplify that, what happens when I multiply 10 to the 6th power times 10 to the 8th power? In case that doesn't make any sense to you, if I were multiplying x to the 6th power times x to the 8th power, what is that? If I have 6 x's times themselves and I put 8 more x's times themselves, all with that I'm going to get, Chase?
14. Oh, plus 14.
It's 14. Yeah, you add exponents. So step number 3 is add the exponents together, because that's what happens when you multiply bases that have exponents. This becomes 10 to the 14th power. How hard is that, Caleb Fisher? Now, here is the part, ladies and gents. Can you emphasize this? I don't know if you do something, highlight something in your notes. There is a step 4 to it. And I need you to write it in large letters. It doesn't happen on this one, but it happens frequently. your answer must, with capital M-U-S-T, be in scientific notation. Okay. This, ladies and gentlemen, is in scientific notation, so you don't have to worry about step number 4. Which should lead you to think there's going to be a time when it's not scientific notation and I'm going to have to change, right?
Yes.
Anybody?
Yes.
Thank you for that. Let's take a look. Before we go to division, let's do one that you're going to have to change. Take a look at this. What if I have 6 times 10 to the 5th power times 2 times 10 to the 9th power? By the way, you should almost have this problem done by now. What's my answer going to be? Multiply the 2 lefts together, write down times 10, add exponents. What do I get? 6 times 2 is 12. Times 10, 5 plus 9 is 14, right? 10 to the 5th times 10 to the 9th is 10 to the 14th. This, if you write this answer down, you would be wrong for the simple fact that this is no longer in scientific notation. Does anybody know why? No, it doesn't have to be in parentheses for scientific notation. Anybody know what's wrong with this? In scientific notation, your number has to be between 1 and 10. And it's a 12. Okay? So here's where most people go wrong, but I'll give you the easy fix. Where's the decimal in 12? It's right here. Where does it need to be? It needs to be right here. Okay, you moved the decimal one place. That is going to change this exponent of 10 over here. And the way I think about it is this. Think about it being balanced out. If you make this number 1 smaller, okay, I went from 12 down to 1.2, so I made it smaller. I have to make the exponent bigger to balance it out. I move this one place, I have to add 1 to that. This should be 10 to the 15th power. Think about it balancing out. If you make one smaller, the other is bigger. And vice versa. One small, other gets bigger. I would very much encourage you to look at your notes when you do this, because after doing this for, I think this is my 3rd year teaching, after doing this for 3 years, I've noticed that people tend to get it backwards, and if they say, well, I made this smaller, so I'm going to make this smaller. No, it's a balancing act there. Ain't that exciting? All right, now, we got that? Because it's going to come into play a little bit later. How does division differ? Question? Do I need to go back?
There was just a question. So, let's say 12 wasn't the 12, it was a 9 times 10 to the 14th, you just leave it at 10.
Yeah, as long as it's between 1 and 10. If it's just a 9, you keep it. 9's between 1 and 10.
Then what if it's 10?
If it's 10, you have to change it to 1.0. It can't be it can't be a 2-digit number. It has to be a single digit. It has to be a number between 1 and 10, but not. Back to this one. All right, division. Guess what's going to be different here, children? Same steps. Number 1, guess what? You divide the left numbers. What is 3.6 divided by 3? Anybody do that in your head? Anybody, please tell me you can. Oh, divide left. Cassie Malis. 3.6 divided by 3. In your head. Now tell me. 3 goes into 3 once, 3 goes into 6
1.2.
twice, so it's 1.2. 1.2 times 10. So that's my dividing my left. Guess what step number 2 is? Write down the times 10 part. I'll do it over here. 1.2 times 10. Now, here we go. What is different between multiplication and division? Let me see if you can pick up this without me saying it. In multiplication, I added the exponents together. With division, you have to subtract the exponents. Now, it might be a good idea for you to write those down, because when you start dealing with positive and negative numbers, things get a little goofy, but in this case, it is 8 minus 5, which is a 3. So this is 10 to the third power. And number 4, again, you need to make sure it's in scientific notation. And this one is. And again, like I said, be very careful with this, because if this would have been a 10 to the negative 5th power, if this would have been 10 to the negative 5th power, what happens when you subtract a negative? This would have looked like this, 8 minus a negative 5, which actually would end up being two negatives next to each other. Subtracting a negative is the same as adding a positive. It actually would end up being 13 because you're subtracting a negative. All right, you don't care. Here we go. Ready? Let me give you one where we have to do a little bit of thought here. 3 times 10 to the 9th over 8 times 10 to the 4th. I shall give you a chance to do that. Follow the rules. Divide the lefts, get your decimal number, put down times 10, subtract the exponents, change to scientific notation. By the way, you are dividing 3 by 8. You're not multiplying those numbers together. You take 3 divided by 8, or if you know the fraction 3/8, what decimal it is equivalent to, that would be good too. Chase seems to be looking at his notes, which is a good thing to do. Chase, do you want to share with everybody what is 3/8 as a decimal?
0.375.
Yeah, well, you divide 3 by 8, you are going to get 0.375. It's in your little cheat sheet that I gave you. This is the fraction 3/8, 8 divided into 3. You are going to multiply it by 10. What is your exponent of 10? 9 minus 4, did you say? 5. Is this right? It is not, because this is not in scientific notation, because it's not a number between 1 and 10. I need to move decimals and change exponents. And again, remember, if you make the number bigger, exponent gets smaller. If you make the number smaller, exponent gets bigger. It's kind of like a flip-flop-flopsy-doodie thing there. Madison says my answer should be
3.75
times 10 to the
6.
I made this one bigger, so this becomes one smaller.
Oh.
Got that? That's the most confusing part about all this. If you make your number bigger, exponent becomes smaller by however many places you have to move that decimal. So yeah,
So if you had to move the decimal all the way like
you will like,
over, then you have to subtract 5 minus 4.
yeah, well, you would, I don't know if that would ever happen. You'd have to get a whole bunch of zeros. You'd have to get something that looked like this. If you got 0.0003 times 10 to the 9th power. If I said change that to scientific notation, what would you have to do? Well, you'd have to move the decimal 1, 2, 3, 4, 5 places to get it to be a 3 times 10. I made this bigger, so I have to make this 5 smaller. And it would end up like that.
Would it ever be like if there was a 5 and 10 to the 5th power and then there was an extra 0, right?
Yeah, you can have negative exponents with this, by the way.
Yeah, what if it was just like 10 to the 0?
I'll tell you what, you give me the problem and I'll fix it for you. Tell me what, give me the problem like you're speaking.
Like 0.
Am I point? Did you say point? Yeah, give it to me. 0.0 what? How many zeros do you want to go?
3 points.
Wait,
Oh,
3 points already in scientific notation. You don't have to change that at all.
3.8. I don't know.
3.8 you're not going to have to change because it's 1.1 and 10. Here, let's take a look at this number. What about
I
this?
don't know.
5,280 times 10 to the negative 4th power. And I said change that into scientific notation. What would you have to do? Where's the decimal going to go? John, where am I gonna put my decimal to make this number between 1 and 10?
Between 5 and 6.
Right, the decimal's gonna end up here, and you have to write the rest of these digits, you don't need that 0. But how many places did I move the decimal? 1, 2, 3. I made this 3 smaller, so this has to get 3 bigger. And what is a -4? Ooh, -4 plus 3 is -1. You can have negative exponents in scientific notation, that is actually perfectly fine. How about this one? 0.000004321 times 10 to the 18th power. If I said change that into scientific notation, what would your answer be? Making it between 1 and 10, and then moving your decimal, and then changing your exponent. Ladies and gentlemen, Zachary Roth is going to divulge his answer to the rest of the class. Zach, what'd you end up with?
4.321.
4.321 is perfect. Times 10 to the who?
11.
I don't know how many places we had to move it. We moved it 1, 2, 3, 4, 5, 6, 7. I made it 7 bigger, so I have to subtract 7 to make it 7 smaller. 10 to the 11 power. Zach, you are a genius. Genius. We need to go any farther before we divulge the results of the last surface area